Alright, how's it going, everybody? The goal for you guys today is to be able to determine if two figures are similar. Alright? So, first off, two figures are similar if their corresponding sides are proportional, alright, and their corresponding angles, are congruent. Alright, so, corresponding sides and angles. Corresponding sides. Alright, let's see, we've got this triangle and we've got this triangle. Well, corresponding sides would be the two sides that are in the same location on each triangle. Alright, so for example, A corresponds to this A. Alright, this large B corresponds to this little b, and this big C corresponds to the little c. Alright, so the C's correspond, the A's correspond, and the B's correspond. Now I could have labeled these with different letters, alright, but this side would still correspond to that side. I could have used X to represent that side, alright? And another thing, the angles are congruent. Alright, congruent means the angles are exactly the same. Alright, so this angle is 90 degrees, that angle is 90 degrees. This one's 60, that one's 60. This one's 30, that one's 30. Alright, that's what makes two triangles, or two figures, in this case they're triangles, similar. Alright, so, number 1 and 2. Alright, we've got them all worked out, but I'm going to explain how we got our answer. So are these figures similar right here? Yes, they are. Alright, so I've got triangle ABC, and I've got triangle DEF. Now I'm going to find out if they're similar or not. Alright, so what I'm going to do is I'm going to set up two proportions equal to each other, and I'm going to cross multiply to see if we get the same result. Alright, so I'm going to take 15 over 18, and the two sides that correspond with 15 over 18 would be 10 over 12. So I'm going to write 15 over 18 equals 10 over 12. Now I'm going to cross multiply. Alright, when I do that, I get 180 and 180. 15 times 12 is 180, 10 times 10 is 180. So, are these proportional? Yep, they're proportional. Alright. Angles, we'll work on similar figures, alright, and deal with angles a little bit more in class, but just for the video notes, we're just going to be worrying about the side lengths. Alright, angles are pretty easy to determine. The side lengths, those are the things that can be a little tricky. Okay, so my next ratio. Alright, I've got 18 over 21. Alright, so 18 over 21 and 12 over 14. 12 over 14. Alright, so now I'm going to cross multiply to see if we get the same thing, and we do. We get 252 both times. So that means that these corresponding sides are proportional. Alright, now the only combination I haven't used yet is I've done 15 and 18. I've done 18 and 21, but I haven't combined 15 and 21 yet. So that's the only combination I haven't used yet. So let's use that. Alright, so I've got 15 over 21 equals, well, 15 over 21, 10 over 14. So 15 over 21, 10 over 14. Now I'm going to cross multiply. Alright, so 15 times 14 is 210, and 21 times 10 is 210. So every single side length, every single combination of sides is proportional to the corresponding combination. So that means that those triangles, they're similar. Yep. Alright, next. Alright, we got a couple rectangles. Alright, so are these similar? Well, you're already going to see that they're not, but the easy thing about rectangles, or whenever you're only given two side lengths, you only have to set up one set of proportions. Alright, you don't have to go through all the different sets, because there's only two possible combinations with rectangles, right? 7 and 4.5. And it doesn't matter if you put the 7 on top or the 7 on bottom. Just make sure that when you set up your other ratio that the corresponding sides are in the correct spot. Alright, so for example, I've got 4.5 over 7. So I did the short side over the longer side. 4.5 over 7. So that means when I set my next ratio, I'm going to put 6.3 over 10.1. So 6.3 over 10.1. And now I'm going to set them equal to each other. Alright? These sides correspond. So they're both on top. these sides correspond. Alright, 7 and 10.1, so those are both on bottom. Okay, just like when we solve problems that involve proportions, alright, in word problems, alright, these have that they're corresponding sides. That's what they have in common. That's what 7 and 10.1 have in common. They're corresponding sides. So 4.5 and 6.3 on top, 7 and 10.1 on bottom. Alright, so anyway, so we cross multiply. When I cross multiply, alright, 4.5 times 10.1 and then 7 times 6.3, I get 45.45 equals 44.1. Those aren't equal to each other, so they can't be proportional. And since they can't be proportional, that means that they can't be similar. Alright? So now what you're going to do is you're going to set up, well, I'm going to give you two problems. You're going to set them up, solve them, and determine if the two figures I give you are similar. Alright? So, last slide. Are those figures similar and are these figures similar? Alright, so what I want you to do is pause the video, give these a shot, and then I'm going to go over them in a second. Alright, so for this problem, alright, we've got rectangles. Alright, we're dealing with rectangles, so this is going to be easy to set up and solve. There's only one possible combination of the side lengths. So let's see. I've got, well, 10.8. I'm going to put that on top of 20.4. Alright, so we got 10.8. Now I'll write this right here. 10.8 over, I'm going to do 20.4 equals, and then you notice this, guys, this rectangle, if you just turn it, alright, that would mean that the 10.8 corresponds with the 3.6, right? Those are the two short sides. Alright, so that means these two side lengths are corresponding. Alright, so since 10.8 is on top, and it corresponds to 3.6, I'm going to put 3.6 on top. So we're going to do 3.6, and then underneath that, I'm going to put the 6.8. So, now what we need to do to check to see if these two figures are similar is cross multiply. Alright, so I'm going to cross multiply. When I do that, let's see, I get 73.44 when I do 10.8 times 6.8. Alright, so I get 73.44. Let's see how I'm going to do this. 73.44. And you know what, let me fix this equal sign so that it makes a little bit more sense. Put it right here. Alright, and then when I multiply 20.4 and 3.6, guess what I get? 73.44. Let me fix that 7. God, that is hideous. 73.44. Alright, we get the exact same thing. So that means that those two rectangles, those two figures, they're similar. Alright, next one. Oh, let me write my answer. Are they similar? Yes. Alright, those are similar. Alright, next, number 4. Are those similar? Alright, well, let's see. Now I've got 3 combinations of side lengths to set up as ratios. Alright, so first, let's do, we do 2, and that corresponds with the 8. So, well, let's do 2 over 5.3. Alright, so we'll do that one first. 2. Oh, you know what? That's a little bit too low. We got 2 over 5.3 equals, well, 2 over 5.3, 8 over 21.4. So we'll do 2 over 5.3, 8 over 21.4. So let's cross multiply. Alright, let's see. When I do 2 times 21.4, two times 21.4 is going to give me 42.8. And then when I do 5.3 times 8, I'm going to get, I should get 42 point, well, hold on, 5.3, 42.4. Oh. Those are not equal to each other. Not equal to each other. Alright. So now let's do 2 over, well, let's check. We'll do 2 over 4.1. Alright, so let's do 2 over 4.1. Equals 8 over 16.4. Okay, so I'm going to cross multiply. Alright, let's see. 2 times 16.4 is going to give me 32.8. Equals, when I do 4.1 times 8, I get 32.8. Alright, so those are equal to each other. And the last one, I already did 2 over 5.3, I did 2 and 4.1. The only combination I haven't used yet is 4.1 and 5.3. So I'm going to do 4.1 over 5.3. Equals 16.4 over 21.4. Alright, last step. Now I gotta cross multiply. Alright, so cross multiply. Bring that down. And to save everybody some time, I'm gonna bust out my calculator. Get 87.74 when I multiply those. You can see that 87.74 equals, you know, let me move that equal sign a little bit so it's not touching. 4. And when I multiply 5.3 times 16.4, I get 86.92. So, are these equivalent? Nope. So, class, in order for two triangles to be similar, alright, in order for them to be considered similar, when you set up all the side lengths equal to the corresponding side length and you cross multiply, alright, they should all equal the same thing. So, these aren't equal, these are, but these aren't equal. Alright, if they're not all proportional, if all the side lengths are not proportional, then that means that the two figures are not similar. So, in this case, you should have gotten no for your answer. Not similar. Alright, so that's it for the video. We're going to work on a bunch of problems like this tomorrow, or, well, for the next couple of days, whenever we get to it. And I'll see you guys soon. Alright, later.